So let me start with the overview of this SkillOS project. Uh, for learning goals, for creating personal learning goals, we cannot, we don't have that context uh, for our previous learnings. So what I created was a system that can automatically generate context from your previous learnings, from the notes that you have generated, uh, that you have created in your, let's say, Obsidian vault, Obsidian notes, and those will be used as a context to create a personalized learning plan. And let me give you the overview of the whole system. Uh, the user is interacting with the system via Slack bot, and all the slash commands are used. Let me share the commands. So these are the commands that the system can accept, and uh, there's a SkillOS command that that triggers this supervisor agent that can automatically route your query to these commands. So this is like a parent command which can invoke all other commands, and these commands can also be accessed directly. And this we have multiple agents for creating a new skill. We have intake agent, and for planning the tasks, though there is a planner agent, and every agent has a separate is deployed as a separate Lambda on AWS, and all the agentic memory is the Git repository itself. So the source of truth for all the system is the Git repository. And let me show you an example. Uh, these are the commits, like when you are interacting with the agent, all these checkpoints will be created based on that conversation. Let's say I just created a new skill for learning multi-agent systems. So what it did was it created this in my active skills active.json. So this file has all my active skills that I'm currently pursuing. So this acts as a memory and also a persistence layer for our agents. So yeah, that's how all the agents coordinate, and all the shared state is in our uh, Git repository and also on our S3 buckets. So how does RAG come into picture? So RAG is being used on our, so let's say, so this is my repository. So all the nodes in this repository are being fetched and converted into, let me, wait. So let me open the architecture diagram for once. So this is the single repository that will act as our knowledge reference that we already know. So this will be fed into our RAG architecture, and all the embeddings, all the document will be chunked and everything, and they will be stored in S3 vectors. And based, and when the user asks for learning something, and relevant information is already present, then the agent will have the context that, okay, the user already knows this based on the already nodes that are present. So I'm using cloud architecture, and it's all serverless using Lambdas. And EventBridge is for triggering nightly events. So at the end of the day, if there are tasks remaining, So those tasks are carried forward for next day. And in the morning, also there is also checking that if the notes are updated. So the notes will be automatically embedded if any new notes are present. Uh, so let's talk about guardrails. I have in the intake agent, I have hard limited for clarifying questions. So when I in when the user asks that I want to learn neural networks, so the system can clarify, the agent can clarify what actually they want to learn, and I have limited that clarifying questions in to 5 questions. So things like that. And for the observability, I have integrated my system to LangSmith. So what we have is for each run, we can uh, trace what everything happened. So in this last conversation, I asked, I want to learn deep agents. So it used 3.2K tokens. So everything I can debug here. And okay, here let's say this was the LLM call, and this was actually the output of that LLM call. So I'm using the AWS Nova Pro, which is deployed on Bedrock. Yeah. So this helps a lot in how tokens are being used, where the latency is being happening. So yeah, uh, I think so. This is the proof of concept that I have created, and there are many improvements that we can do, like we can add much more. Oh, okay, let me share one more thing. So these are the prompts that we are actually pulling from the LangSmith hub. So this is like a repository for all the prompts. So these are the prompts that our agents are using, and these can be versioned. And if they update, then we have all the history of yeah. So I think that's it. Uh, so let's say I want to learn. Let me show you a demo. Learn uh, mm, neural networks. Something. Neural networks foundation, and this will trigger the supervisor, sorry, the intake agent, and it failed somehow. I don't know. Let me try again. Okay, now it is okay. Again, it's failing. So yeah, sometimes it gives response. And what specific aspect of neural network foundation? So this is a clarifying question that the agent is asking me. And let me say, I want to understand neural networks, their architecture and optimization, most of the foundational concepts. And I will add the command. So it will be routed to the same agent. And this is a lazy architecture. So it it has to respond quickly because Slack has 3 second, like in within 3 seconds, you should send a response, otherwise it breaks the connection. So great. I've put together the skill tree. So if we check our GitHub repository, so let's say, let's see our GitHub repository. Now there must be, okay, add neural networks foundation. So the agent created this git commit and named it add. neural networks foundation, and actually added those files when the self skill was created and the difficulty level the user has requested. So yeah, that's it.